Hello everyone. Our today's topic is symmetry, and the first topic is line of symmetry. Look at the following figures: A, B, C, this oval, this circle, triangle, square, rectangle, and parallelogram. Each of them is such that if one of the figure is folded, like if I fold this and unfold it, so it will exactly coincide with the other. It means we cannot see the below one part of this letter B because this is hiding this part exactly. Such type of figures are called symmetrical figures. And the line which divides the figure into two congruent parts is called the line of symmetry or the axis of symmetry. In this figure, let's see where is the axis of symmetry. If we fold it here, this is the axis of symmetry. And if we fold it like this, so this is the axis of symmetry. So there are two lines of symmetry. This is a circle. We can get as many lines of symmetry as we want to fold it, or we can say uncountable line of symmetry in circle. In this triangle, do we get any line of symmetry? Let's see. If we fold this triangle like this, few part of this triangle is visible. It means it is not hiding or coinciding. This part is not hidden by this part. So this is not having any line of symmetry here. So this is not a line of symmetry. In this square, we have four lines of symmetry. 1, 2, and diagonally also we get two lines of symmetry, one here and one here. So overall 4 lines of symmetry. In rectangle, if we see, one line of symmetry is this and one line of symmetry is this. Rectangle is not having any line of symmetry diagonal. Why? Because when we fold it like this, one figure doesn't hide the other figure exactly, or it is not congruent. So we will not say that it is having any diagonal symmetry. So there is no diagonal symmetry in this rectangle. This is a parallelogram. Parallelogram is not having any line of symmetry. See, in any manner if you fold it, you will not find that it is hiding one figure is hidden by the other figure. So there is no line of symmetry in parallelogram. Note, a regular polygon has as many lines of symmetry as the number of sides. Like if we can see, this is a square. A square is having 4 sides and it is a regular polygon of 4 sides. So it is having 4 lines of symmetry, and always we know line of symmetry can be represented by a dotted line. Rotational symmetry. In our daily life, we observe many objects which rotate. For example, hands of a clock, a wheel of motorcycle, a ceiling fan, lid of a jar when the jar is closed or open, etc. Rotation takes place about a point. This point may or may not be in the center of the object. So the point about which an object rotates, it's called the center of rotation. And it can be clockwise or anti-clockwise. For example, if we observe these pictures, and we hold this thumb pin and we start rotating this about this point. So this point is the center of rotation, and it can be rotated clockwise direction and in the anti-clockwise direction as well. We can see here also. In this also, we can rotate the figures. If we hold them tightly, and then it will rotate easily. A figure is said to have rotational symmetry about a point O, which is called the center of rotation. This is O, this is O, center of rotation. If by rotating it about this point O, it fits in its outline, this is the outline. So if it fits in its outline at least once, you can see here the A and this A. So once it has fit, before it completes the turn, and A meet at A again, B meet at B again. So this is called the rotation center or center of rotation. It need not to be exactly in the center. We can hold it anywhere here only for the purpose of rotating it around this point O. And by rotation, moving like clockwise direction, in the clockwise direction, it is clockwise rotation, and in the anti-clockwise direction, it is anti-clockwise rotation. And when an object rotates, its shape and size do not change. Order of rotation. When a figure fits exactly onto the outline of the figure a number of times in the process of rotating back to its original position, called the order of rotation, and magnitude is called the angle of rotation. So let us take a few examples here. Let us find what is the order of rotation in these following figures. I have made already outline of each figure here and kept this cutout of all the figures and labeled them as A in the cutout also and in the outline place also, B here. Now if I rotate it either clockwise or anti-clockwise, I will check how many times each figure will fit onto the outline of it, and that number of time is called its order. So let's begin. This A letter will come up after taking a turn back to its original place, and before taking this complete turn, how many times this figure fits in its outline, we have to check this. Let's start rotating clockwise direction. We find that this A is coinciding with this letter B, and we can observe this figure that it fits in the outline one time, but the A is not reaching to this A. It has to reach there. Again I am starting the rotation following the same clockwise direction, And now I can observe here that this A has come back to its A letter and this B has come back to the B letter. So for 2 times we can find that this figure fits onto this outline. So it means it is having 2 order of rotation. In the same manner we can check all these. So 1 time it fits here in letter Z and then 2 times. So it means this letter Z is also having the rotation order 2 here, and this is having the rotational symmetry. Similarly, let us take for letter S. We rotate it. This time I am taking the anti-clockwise direction rotation, and then we can see here. Let's begin it from here. This is A and A first. Let us match this and then we start rotating. And then we can see how many times it fits into the outline. So 1 time it fits, but let this A reach to there. So then complete circle will be covered. So it is now. So it is having 2 order of rotational symmetry. In the similar way, we can check for each and every figure. If here in this parallelogram, we can check this out. So we need to find out whether it is having how many times it fits in its outline. We can find it here. 1 time it fits, right? And 2 times. So this is having 2 order of rotational symmetry, and yes, it is having the rotational symmetry. Let's check for this triangle whether it fits or whether it is having the rotational symmetry. After doing this work, we can find that it is not fixing its outline anytime. Just 1 time it fits when it takes complete round. It means it is having no rotational symmetry in it. Thank you for watching.